Hi, I'm Courage, Phys 2, let us start.
Hello, my name is Tiana Morrison. I'm a computer science junior, and I'm in Dr. Store's Monday, Wednesday, 2 o'clock class.
My name is Kenneth Sugonyali, and I'm a mechanical engineering major, and we're all taking physics 2 with Dr. Store, and this is our project, our last project for the semester, and yeah.
Okay, so today we will be working out how to, one, find the charge within the capacitors, and then also calculating the total charge. So I will start out first by drawing the resistor up here. Okay. Can they see that?
Yeah, they can.
Okay. Okay, so on this side here, we have 20 volts. We have 2 here, 4 here, 1, 3, 2, 5, and 3. Okay, and so to make it easier, what you can do is you can just simply opt out the numbers and plug those in with a chart that basically is going to tell you and make it easier to do your equations in, which is by the variables. And I'll show y'all how to do that right now. So basically what I'm going to do is I'm just going to label the capacitors by basically by numeric order. Okay, so for example, since we have 20 volts here, then we'll just call that as V. And then we have our first capacitor, our second capacitor, so we'll just go down like this in numeric order. This would be C3 here, C4, C5, C6, C7, and C8. And when we move on further into the problem, you will see why doing that makes it easier for you. And let me see a marker. That black marker. Thank you. Okay, so from now on, we will begin to cancel out all of the ones that are in series. So for example, series is when they are sharing the same exact charge, and parallel is when you have to go from here to here when they are not on the same charge, when the inductor separates that charge. So for example, to solve this first one here, we want to solve this one first to cancel that parallel out. I'm sorry, to cancel that series out. So we have series is C1 and C2, and how you solve a series circuit is you do it by the inverse. So for example, you have C12 here. And to solve by the inverse, that means you're putting that equation over 1. So for example, we have 1 over C1 plus 1 over C2. So C1 is C2. We'll have 2 times 4 over 2 plus 4, which is equal to 8 over 6. So the charge on that circuit is 1.33. And what I just explained is how to, one, write the capacitor, and two, how to make it more simplified when you do your equation. So you can just remove those numbers and make them by variables with the C's for the capacitors, the V for the voltage there. And then I also taught you how to solve in series. And in order to solve in series, you have to put it in inverse. And then to do the inverse, of course, you have to do the 1 over the actual number that you were trying to solve.
And I'll be continuing the rest of the series to show you, like, if you solve it, like, what you would get from it. And then I'll be doing C4, C5, and also C6 and C7. And then for C4 and C5, you basically have to solve it this way. Which is basically choose 1 over C4 plus 1 over C5. And that's equal to C4 over C4 plus C5, which is basically equal to the numbers 1 times 3 over 1 plus 3 is equal to 3 over 4, and that's basically equal to 0.75. And for the C5, I mean for the C6 and C7, you basically just have to do the same thing. You just have to switch the numbers up. It's C6, 7 equal to 1 over C6 plus, which is basically equal to same thing again. Just have to repeat the same thing with different numbers. C6 times C6 plus C7 is equal to 2 times 5 over 2 plus 5, which is 10 over 7, is equal to 1.42. And what I just did right here, I just solved how you get the series and how you get the right answers for it, and how you get the forces for it. Yeah, basically that's how you solve it for the rest of them.
Because since we've gotten all the values for all the series, so I'm going to change this circuit, this capacitor here. I'm just combining it. It's going to be so I'm going to call it C45, since they're the same. Then this one, I'm going to call it C12. Then this one is C7. I'm going to call it C7. So since we got all the values for the capacitor, I'm going to calculate the total now. So C is going to be the total C is going to be C equals to C12. Since they're all connected in parallel, so it's going to be C12 plus C3 plus C45 plus C67 plus C8. So it's going to be the value for C12 is value for C12 is 1.33 plus 1.33 plus 5 plus 0.75 plus 1.42 plus 2 plus 3. So the total C is going to be 11.5 Faraday. So now I want to get the total current and charge in the whole capacitor. So it's going to be the formula is Q the formula is Q equals to CV. And I mean the C total. So we're going to get 11.5 times 20 volt, which will give us 230 C. So that's our final answer for this whole problem, the total charge. Total charge. So that's the final answer. Yeah.
Alright guys, so within this video we have successfully taught you how to, one, solve a circuit in series and also in parallel, and to get the total charge of the entire circuit. So my name is Tiana Morrison.
My name is Owhonda.
My name is Aniya Facion.
And that concludes our video.
Thank you to the start.